By the fall of 1940, Nazi Germany had conquered most of Europe, leaving Britain to stand alone. Their survival rested on a fragile supply line stretching across thousands of miles of open ocean. That lifeline was under constant attack. German U-boats were aggressively hunting in the Atlantic, sinking Allied cargo vessels much faster than they could be replaced. In response, the United States launched an emergency shipbuilding program. Across 18 shipyards, thousands of workers focused on a single massive goal: to mass-produce replacement cargo ships at a speed the world had never seen. Military might alone was no longer enough to win. Allied survival now depended on a pure industrial race against the clock. To solve this manufacturing crisis, the Allies didn't look to the future. Instead, they resurrected a 60-year-old British cargo design dating back to 1879. This diagram compares a modern cargo vessel hitting 22 knots against the Liberty ship, which topped out at a sluggish 11 knots. Designers chose this unrefined, technically outdated vessel as the backbone of the Allied supply effort. This choice creates a massive paradox. Why would military planners deliberately bet the outcome of the deadliest war in history on technology that was already obsolete? The Liberty ship was engineered for availability, not performance. To meet the demand for volume, engineers had to strip away every complex, time-consuming manufacturing step. Builders discarded traditional riveting in favor of welding prefabricated sections. It was a faster, more direct way to fuse the ship's hull. These prefabricated sections were dropped into place and welded instantly. Timelines that took several months were suddenly finished in a matter of weeks. This simplification allowed a workforce of civilian laborers, most of whom had never built a ship, to join the production line and keep the yards running 24 hours a day. By removing the need for specialized craftsmanship, the Allies turned complex shipbuilding into a high-speed assembly line. This same logic dictated the engine. Designers bypassed modern, high-efficiency steam turbines for a massive vertical triple-expansion steam engine. Precision turbines required rare materials and specialized manufacturing that were in short supply. This older engine was simple enough for almost any civilian machine shop to build. The process begins in the firebox, where forced air and atomized fuel mix to create an intense flame. Feed water circulating through generating tubes absorbs this heat, converting it into high-energy, superheated steam. This steam is directed through 3 vertical cylinders of increasing size. As the steam expands, it pushes each piston in sequence, extracting energy at 3 different pressure levels. This drives the crankshaft to rotate the propeller. The spent steam then enters a condenser, turning back into water to begin the cycle all over again. This simple mechanical loop bypassed the era's manufacturing bottlenecks, providing the reliable power needed to keep cargo moving across the Atlantic. A single Liberty ship could carry 9,000 metric tons of cargo, the equivalent of more than 250 fully loaded semi-trailer trucks. Because many European ports had been destroyed, the ships were equipped with their own steam-powered derrick cranes. They could load and unload military equipment anywhere without needing dockside rope. The steering system was equally rugged, using heavy tiller springs to absorb the shock of rough seas and protect the rudder mechanism during storms. To survive the crossing, the ships featured up to 100 millimeters of asphalt composite armor and multiple deck guns manned by a dedicated Navy armed guard. This made the Liberty ship a fully autonomous, armored warehouse capable of delivering its cargo independently to any coastline on the globe. Between 1941 and 1945, the United States built 2,710 Liberty ships. This chart shows how production eventually overwhelmed the enemy. At its peak, shipyards averaged 3 completed ships every 2 days, far outstripping the rate at which U-boats could sink them. Relentless production rendered the German blockade mathematically impossible to maintain. The Allies simply outbuilt the enemy's capacity for destruction. In this industrial race, sheer volume proved to be a more effective weapon than technological sophistication. While the Liberty ship held the line during critical years, its slow speed led to the 1944 Victory ship, reaching 22 knots. Only a few of these original vessels survive today, like the SS Jeremiah O'Brien, which serves as a reminder of the era's frantic manufacturing pace. The SS John W. Brown remains as one of the last two operational ships of its kind. By replacing specialized craftsmanship with standardized, prefabricated assembly, the Liberty ship program proved that complex machinery could be mass-produced at an industrial scale, providing a blueprint for the modern era of global manufacturing.